Hi, Mr. X with glossary term complex conjugate. To get the complex conjugate of any complex number, we change the sign between the real and imaginary parts. So the conjugate of a plus bi is a minus bi. The conjugate of c minus di is c plus di. And we do this to get a real value in the denominator of a complex fraction, because then they're easier to deal with. So a quick numerical example might be appropriate. Suppose we have 3 plus 2i over 5 plus 4i. Well, what we're going to do is we're going to multiply by the complex conjugate of the denominator, and that will give us a real denominator. Now, is this legal? Can we do this? And the answer is yes, of course, because we started with this thing. That's what we started with. And we're multiplying it times 1. Well, you can always multiply times 1. That won't change anything. And we multiply these binomials, as it were, 3 times 5, 2i times 5. Oh, by the way, if you're used to doing FOIL and you will want to follow along with me, I usually do FIOL, just a habit I got into. I do the inside products, the 2i times 5 I do before I do the 3 times the negative 4i. It's just a habit I got into. I do FIOL. And then 2i times a negative 4i would be a negative 8i squared. On the bottom, this looks very much like factorization of the difference of two squares, and it is. Whether you do FOIL or FIOL, the middle terms drop out. The 20i and the negative 20i cancel one another. That's why we do it. This is going to turn real, because anytime you have I to an even power, that's going to turn real. And I raised to an odd power stays imaginary, and I raised to an even power goes real. So let's clean this up. Well, let's see. The negative 8i squared is actually a positive 8. And we can add this positive 8 to the 15. So we have 15 plus 8. This is a real 8. A negative 8 times a negative 1. It's a positive 8. So we get 23. Looks like minus 2i. And on the bottom, 25 minus 16 times a negative 1. So it's going to be 25 minus a negative 16. And while some people like it just the way it is, some people say you're done, other people like to see it broken out into the real part and the imaginary part. Either way, we use a complex conjugate quite often to get a real denominator so that we can deal with things. MrXmath.com